has anything to say about the deindustrialization of this country.
Georgian townhouses on the moon, the highest GDP per capita in the Milky Way. Small modular reactors under every village green. This is Anglo-futurism.
Welcome, listeners, to the Anglo-Futurism podcast. Today we're broadcasting not as usual from the KC3, but instead have ventured down to Earth in Tom's rickety blue space shuttle, VW space shuttle, actually. And we're here with Sam.
We're here in Harwell, in a magnificent business park with space startups and a huge synchrotron as well. And we are here to meet Sam Adlen from the company Space Solar. Sam, welcome to the show.
Great to meet you both.
So I'm going to have a go at summarising what your company does, and then perhaps once when I've intellectually swallowed myself, you can correct my mistakes and tell our listeners what's actually going on. So Space Solar's plan is to beam down solar power from space to Earth, and the point is that beyond the clouds, it's 24/7. It's more powerful. All you have to do is set up some kind of huge laser with receivers at either end.
Very good until the laser bit. Yeah, you've got the essence of it perfectly right. So yeah, high above the clouds, the sun shines all the time, so you get 24/7 baseload power. If you put a solar panel up in space, that same solar panel compared to a panel on the ground gets 13 times more incident energy, and that's what really drives the economics and rationale for space-based solar power. You get 24/7 baseload power. It's incredibly scalable. These are large systems, but you've got mass production economics. You've got a low great environmental footprint, about half that of terrestrial solar. And you've got this incredible flexibility because from a high Earth orbit, you can see a third of the Earth's surface and instantaneously switch the beam to points of demand. So we're looking at costs that are as good or better than terrestrial solar, and something that can be a hugely important part of the future energy system. So you were bang on, apart from the laser bit.
Well, I was going to say, if Tom sort of only mildly soiled himself,
It's a great result for
exactly.
Night out.
Better than most Friday nights with Tom. If it's not a laser, what is it? How is the power?
Yeah, so we use high frequency radio waves, microwave. Basically, anywhere in the frequency range between 1 and 10 gigahertz, the atmosphere is effectively a window. So you choose a frequency there, and then we transmit it down in a very low energy density beam. So the maximum power density is about a quarter of that of the midday sun. So it's designed to be safe. Another bit you may have, The birds are absolutely fine.
Well, we did bring an egg in the hope that you'd be able to cook it for us.
Well, I could certainly cook you an egg, but not with our space solar power satellite.
And how did you start doing this? I mean, there's no grad scheme for beaming solar power straight to Earth.
But there should be.
There will be. No, indeed. Well, my career's been predominantly in the space
You were an
sector.
Oxford Rugby Blue, right?
A long time ago.
So you actually emerged with a suitable number of IQ points to be developing a whole new form of baseload power.
Good. How brilliant were you before you did the rugby?
Well, I do sometimes question. No, rugby was absolutely superb. But yes, I was a physicist and a rugby player, which is not unique. I had a number of friends actually that were physicists and rugby players, but it's not that common. Yes, certainly the rugby, not so much these days, as you can see. And in fact, the physics as well. But both of those two things led me on a journey into the space sector. Started off looking for water on Mars, which I did a reasonably bad job of. People have since discovered there's loads. But that was my PhD, and I've been in the space sector ever since. And The latter part of my career, I spent a decade at the Satellite Applications Catapult, which is the UK's main innovation centre for space, where we look at how space can benefit the Earth. I've always believed in it's next door, so almost by definition, solutions to the planet's biggest challenges are in part going to come from space. And it was just very clear 5-6 years ago that concepts like space solar power, which require they're large structures, not new. We've got a comic next door, the original magazine where Isaac Asimov first mentioned space solar power back in 1941. There have been concepts ever since the 1960s. They've always been considered technically viable, but the economics have always been reasonably poor because of the cost of launch. That's changing due to Starship and other heavy reusable launch, and suddenly this becomes something that can be a hugely important part of the future.
Did NASA successfully demonstrate this, like the Goldstone experiment?
Wireless power, that's right. So back in the 70s,
What range are we talking?
They did terrestrially. That was sort of kilowatts over kilometers, basically.
Which Tesla himself was trying, right?
Yeah, indeed. This is one of the beauties of what we're doing. There's no new physics involved. This is stuff that is stuff that you can write. We can write down all the physics on a board today. There's nothing new there. It's an engineering challenge. And it's about engineering the economics.
I'm going to pop on my VC baseball cap now. Turn it back around, and I'm going to ask why nobody's done it before.
Space-based solar power.
Yeah.
Well, it has been a cost of launch thing. So until with today's launch costs, actually, we can be looking at levelized cost of electricity of around $30 per megawatt hour for mature systems, which is pretty much as good as terrestrial solar. If launch costs drop, as analysts predict, we can be below $10 per megawatt hour, which is incredible for baseload power. And so no one's done it before because the systems are large, and you've got to have that capacity to orbit, and you've got to have a launch cost that works. And that's what's starting now. And so, we're seeing VC money coming towards it. It's brilliant. There's been about $100 million of private investment into companies that are actually doing laser-based space solar power to start with. That's got really strong. So you can. There you go, Tom. You can
slip some IP.
You can also do it with lasers, and it's good applications, particularly for defence. You get a smaller ground footprint, but you do have the safety issues and actually lower conversion efficiencies. Atmospheric absorption means it's not a solution for baseload power, and it's not a solution for the sort of scalable power that really is going to drive energy security and net zero and all the things we need. So it's really important, but it's an application, but not the scalable sort of massive grid scale power.
I think we should come back to space lasers. So,
it's basically the only thing that I'm interested in. Okay. The only reason I'm here is basically to say, come on, when can we zap them?
But let's get a picture of how it actually works. So you have satellites with solar arrays, and are they geostationary directly above some kind of receiver?
We can use a range of different orbits, which is, again, one of the advantages of our particular solution. Ultimately, for gigawatt scale power, you're in geostationary or geosynchronous orbit. Geosynchronous, it's less crowded, so that we're actually using geosynchronous orbit.
Are they the ones where they launch north?
That's the low Earth polar orbits.
Okay.
Which are our MVPs. Our minimum viable product is for actually providing polar power. So you can do that from when you're closer in, your systems are smaller, and then you pass over the poles pretty regularly. And as activity increases there, there's good utility and interest. So yes, Tom, we're in a geosynchronous orbit. Let's talk about the gigawatt scale systems. And so you've got large arrays of solar panels. For the gigawatt scale systems, you're looking at kilometers in diameter. So
these are how big the panels are.
These are how big the panels are. That's right. So it's for our gigawatt scale system, you're looking at 1.4 kilometer diameter. But the systems they're hypermodular. They're comprised of hundreds of thousands of the same coffee table sized power modules, which include the PV and the RF electronics and the antennas that then transmit that out.
So you actually have lots of little antennas that are broadcasting rather than one big one.
That's exactly right. Yeah. So that's part of the reason why our system is safe by design. So each of these power modules does exactly the same thing, but they're completely independent. And it's the fact that they have a very precise phase reference for the signal that's transmitted means you can recombine that coherently down at the receiver and reconvert that back into electricity.
And when you're saying safe by design, I imagine you're saying thus it can't be converted into a microwave your neighbor kind of machine.
Indeed, that's exactly right. Physics is helpful and unhelpful in some ways. So it's physics that means that the systems are large, but it's also physics that means that the systems are safe for us. So there's this concept called diffraction, but basically when you put a wave through an aperture, dependent on the relative sizes of those two things, you get more or less spreading of the beam as it comes out. So microwaves are relatively long wavelength, which means you need relatively large apertures to get your beam to, certainly from 36,000 kilometers, even a small divergence becomes a pretty large divergence by the time you hit the ground. So that's part of the reason why you end up with kilometers in scale. You also you need that much collection space as well. But diffraction means that even if you tried to focus that beam as hard as you possibly could, you've got a kilometer scale size spot on the ground, and you've got the sorts of power densities that are safe.
So if you come to here, can you see where there is, you can see almost like slight shadowing.
Yeah. Oh, yeah. What if the light's coming that way?
Yeah. So what that means is here we would have all our photovoltaics.
On the sort of leading edge.
On the leading edge,
yeah.
But also on the bottom, so you can see where there's a leading edge there.
Right. Okay.
So
and that is this bit.
It's that bit there.
Yeah.
So this is what this means is that every single part of it is always used all the time, wherever in the orbit. That's the clever bit. The unfortunate bit is means that it's a 3-dimensional array, and only people have only built flat panels, like 2D arrays. So we then decide. So first problem is we've got a really clever idea, but no one's in the world's ever built one.
But I suppose these are flat panels. They're just arranged in a helical way.
Yes. So normally the flat panel is in this direction, not
sure.
in this direction.
Sure. Yeah.
So this is the world's first 3-dimensional retro-directed phased array. So we used all off-the-shelf components. It took us about 6 months to build, and this entirely confirms all the models and all the calculations. As I say, this is a perfect scale model of that really big device.
And this is the transmission, not the photovoltaics.
So again, you'd see the photovoltaics on top of here. Of course, we don't want to do that because we would be subject. So this went into a anechoic chamber in Queen's University, Belfast. So perfectly aligned, stopping reflections of RF.
Right.
So when we measure the RF coming from this, we're not getting reflections. And if we had PV, anytime a cloud came over, well, we were indoors most of the time.
You would get a signal.
You wouldn't. The signal would vary. And is it us? Is it the sun? What is it? So we actually feed the power underneath here into this device. And so what we showed is that we can indeed do a full 360 degrees, and we can go up and down for about plus or minus 40 degrees. And so what it shows is that we can wherever we are within the orbit, we can always point at the sun, and we can point at anywhere on Earth with this. Obviously, a single system sees around of the quarter of the globe. So what it means is we can point at a rectenna, and then within milliseconds, we can point to another country, another continent.
And
so
automatically
just moves across. And it does that by, we have where the receiver is, it provides an encrypted beam, an encrypted signal to the satellite, and the satellite itself understands. It then, within the encoded information, it knows where to send the beam.
Sure.
And it does that by a thing called phase conjugation. So basically, you send a signal, which is just a kind of sinusoid. We've got a lot more signal in that sinusoid.
Yeah, but it's an analog signal.
But the way to see it, it's a sinusoid. This first antenna receives the phase of the sinusoid, but right at the back it will be delayed.
Yeah.
And then it's just time reversal. So when it all sends it this way, they all meet up and they all join up together.
Right.
And so we now...
And that's how you know where it is on the...
Exactly.
Yeah, exactly. Yeah.
And so this is... We need to make it a little bit bigger. This is 0.5 meter. We need to get to 1.8 kilometers. But let's go steps.
Get your soldering iron out.
Exactly. but these circuits were all based on what could we get off the shelf components. What could we get as cheap as we could just to show it would work. We're now on our 5th generation of circuit design, so we're now starting to improve efficiency. We're looking at how we can position the antennas to get the most signal out, and so we're just on that kind of journey.
How close are you to actually achieving this? We've been in your office, we've seen some kind of apparatus that looks like it might eventually become a satellite. How long till that kind of thing goes into space?
Our first space demonstrations are in 3 years' time. Our first commercial, we have a pilot plant in 5 years' time, so about 1 megawatt in space, not very much on the ground, and a first commercial system for that polar power in 6 years' time. But we've already got demonstrators today of this. So our magic source is the ability to beam in 360 degrees with no moving parts. So one of the other nuances of being up in space is, as you go around the orbit, the angle between the sun and the Earth changes, which again, a bit of a pain. So historically, many designs have had large rotating mechanical joints, which are heavy and they're a single point failure. Those sorts of joints in space you just want to avoid if you can. So we can beam in 360 degrees, a bit like a lighthouse, but with no moving parts. It's like a 3D phased array radar. Anyway, that means we can use all the parts all the time. It lowers the mass, massively improves our economics. We've got a ground demonstration of that, and we've got a ground demonstration then of our assembly robotics, which will ultimately go into space and construct these systems.
Because that's the second part of it, isn't it? That you're not just going to send up the completed machines. It's what you'll send up the parts, then they will be assembled. And why is that? I mean, I assume it's cheaper to assemble on Earth, and there's less risk. Why assemble in space?
Well, because you do need these large systems for the reasons we've just talked about. And so even with something like Starship, which we had the successful launch last week, which was brilliant, you're still limited by the size of the rocket fairing as to how much the size of the thing you can put out, unless you either deploy or assemble. So you'll be able to put up tons more capacity. Starship's looking at normally around 100 tons to orbit. But you can either have something that's Starship shape and weighs 100 tons, or you can have lots of things that you can assemble into much larger structures. So again, the solar power satellites we're developing are super lightweight. It's a whole new way of using space. My view is that this is exactly how the whole space sector will progress over time. It's just a performance thing. So you end up with super lightweight power modules, very thin, designed to if debris hits it, it's like tearing paper rather than shattering glass. But that lightweight means you can obviously pack stuff in, then assemble and deploy it up in space.
Who are you hitching a ride with when you get the stuff into space? Is it SpaceX, or are you going via Sachs of Ward?
We are, I was going to say we're launch agnostic. We will need heavy reusable launch, but not for year 10, until year 10 on our plan. So we can, everything to that point, we can use today's launch systems. For some of the earlier stuff, there's the potential to use Sachs of Ward, which would be brilliant from a kind of UK PLC
Very
perspective. Exactly.
We won't talk about the size of the rockets.
Yeah, and ultimately it's then heavy reusable launch. So it's SpaceX, it's Blue Origin. I mean, my view is, again, every certainly major block or even nation will end up with heavy reusable launch. It's that strategically important. It's not just about space solar power, obviously, that is so important.
I suppose I've got two questions, and so I suppose what you were saying about the predictions of launch costs.
Yeah.
So for you, basically, there is a point at which that cost curve comes down enough, and then you're ready. So at the moment that it hits that point, you can then go.
Yeah, I mean, for us, it's more about intersecting a capability curve than a cost curve. Because I think I said earlier on, actually, even with today's launch costs for mature systems, I mean, you've got to go through the iterations that get you to the sort of mature system performance. But even with today's launch costs, we can be better than terrestrial solar. But it's about intersecting Starship on its trajectory. So I mean, I saw a tweet from Elon Musk today saying, yes, he says in 6 to 7 years' time they'll be launching more than 24 Starships in 24 hours, which is incredible. I mean that just transforms the way we can use space. And whether or not it's exactly then or takes a little bit longer, the point is that even if a small percentage of that forecast happens, then space solar power is economically feasible, and we can be doing some very, very brilliant things with space.
And are you just gambling that we won't be able to have nuclear power enough to sustain a grid in that period?
Our perspective is that we need all nuclear energy sources. Actually, people used to talk about energy demand doubling by 2050, and even that was a challenge. So on the wall in our office, we have a countdown clock, which is one that Dave, our CTO, has had for many years. He was the chief engineer in charge at the world's biggest fusion project. And when he started, it was 17,000 days till 2050, and that was looking pretty punchy. We're at 8,000 now, and it equates to a nuclear power station a week, or something like 100 square kilometers of solar panels every day to try and reach that net zero target by 2050. That was when it was doubling. It's now expected to quadruple because of the onset of AI and all of that. So we need all these clean energy technologies. Space solar power is incredibly complementary. It really makes the whole energy system work because you've got this. You've got three really important characteristics. It's baseload, so that's actually continuous power. It's dispatchable, so you can tune it, so you can actually sort of balance the grid. And then you've got this flexibility, ability to switch it between different points of demand. So you can actually, when your wind's not blowing over there and your sun's shining there, you just
so you could almost be balancing the grid.
Balance the grid
by targeting it. Yeah,
spot on. Yeah. So Imperial College did a study just looking at the UK. 2 gigawatts of space solar power saves over £1 billion a year in energy system costs because you don't need to overbuild wind and solar. You can instantaneously export, and you can switch between points on the grid in the UK to avoid grid congestion. Imagine that.
You need far fewer transmission lines.
Exactly, it's like a giant interconnector up in space. So to your question, Tom, it's very complementary compared to nuclear and other things. We certainly hope nuclear fusion works. We hope nuclear fission works. Our concern on nuclear fusion, even if it does, well, so I mentioned Dave, our CTO, he thinks it will work, not quite sure on the commercialization timescales. It's about the end-of-a-kind economics and the scalability. That's where space solar power really sings, because I think it's hard to imagine that it won't look like nuclear fission in terms of the end-of-a-kind economics. These are, even if you're mass producing them, there's going to be a few of them. They're all going to be relatively bespoke systems, and they're incredibly complicated machines. What we're producing is basically mass production mobile phone electronics. You can chunk it out. It's dead simple. And so, if you want another 10 gigawatts, well, we ramp up the production in the gigafactory, and there you go. We launch it into space, and you've got another. And
then it self-assembles onto the array.
Or a separate array. But
array.
Exactly. So it's the scalability and the fact that you can get baseload power cheaper than intermittence that's really going to make this an important part of the
future. So for the average Brit, this means they won't get power cuts. Energy will be cheap.
Absolutely.
Well, although I suppose it depends on what you need to receive it, right?
Yeah.
Because when you said a kilometer spread before, is that, do you need to have a kilometer-sized kind of back garden to be able to receive it?
Could you put it on top of a car? It's very dangerous.
If you wanted a personal supply, you would need a kilometer-scale back garden.
Tom, we're working on that exactly.
Yeah. So you can have the first system in your back garden. So they're kilometer-scale rectennas as well, range between about 1.5 and 3.5 kilometers, depending on the size of the system. but they're a sort of transparent mesh-like structure. They look like a giant fruit net on poles. So the good news is it's transparent. So you could grow crops underneath it. You could overlay over a terrestrial solar farm. You could overlay over a data center. The low impact, lightweight structures can be integrated very nicely into the landscape and into the energy system. And they're about 40% of the land area of terrestrial solar for equivalent energy output.
Okay.
So, there's a balance between sort of energy density and the size of your system and the ability to deliver baseload. This is space solar power is in a really nice spot between good energy density and so you've got the low energy density renewables on the one hand, which don't give you baseload. You've got your very high energy density sort of nuclear and that kind of thing. We're in a very nice sweet spot where you've got the energy density and you're able to deliver systems of a workable size.
And then, to what extent are you in a national sweet spot? Is this a good place to be working on this kind of tech? I mean, we were bemoaning recently that the UK Space Agency has been folded into a bigger government department. Shouldn't you be, I hate to say it, but shouldn't you be in California?
Well, I believe the UK can be absolutely the right place for this. We're a great nation of innovators. I do have frustration. So I think I mentioned worked at this satellite applications catapult for a decade, which is all about UK economic growth. And some of the challenges that were spoken of a decade ago, they still exist. We're great on the ideas in the UK, but we're not very good at scaling. I do get the impression with the language changes that I'm starting to hear from government and civil servants that they really do want to make a material difference and look at decacorn type businesses and things that can, really drive transformational innovation. So I'm somewhere between hopeful and confident that we will be able to make this work with a UK leadership position. It will be an international endeavour in the end. There's little doubt that there's strengths to being in the US. Europe's a natural partner. Japan is strong on this. There's all sorts of options for how this can grow, but certainly hope that it can be a big success story for the UK.
And you mentioned there the government and civil servants. How much of it is a sort of regulatory block versus, say, talent acquisition versus, say, capital? What are the hold-ups for you?
You've picked certainly two.
all of the above.
Yeah, well, the top two would be probably financing and regulatory. Regulation's been great, actually. Government have been superb. We've had regulatory working groups pulling all the key regulators together. So you've got Space Agency, CAA, Ofcom, DFT, and the sort of message from that is the plan that we've talked about, the sort of commercial power in 6 years, is deliverable with political will. Great. But financing is a challenge. We're a startup, and it's well spoken about and recognised that financing of early stage infrastructure business, energy infrastructure businesses, is challenging because your typical venture capital type system set up to really like low capex software businesses and kind of revenue in 3 years.
I would say you don't look like a sort of typical startup bro. I mean,
me? Oh dear.
I know. I think you could do a lot more. Sort of tattoos, maybe long hair.
Well, the hair might be past me. I could possibly do extensions. The tattoos I've not really considered, but yeah, well, who knows? If you think it'd help.
Well, there you go. Yeah. Although maybe actually, given my own failure of raising money, actually maybe I shouldn't be any kind of
getting tattoos
exactly.
Yeah. But no, we're getting good interest now. As I said, there's been about $100 million of private investment gone into space solar power now. So the conversations are extremely different, and with the right support from government, this is something we can mobilise at pace.
And you say right support from government. Are there any things that kind of within 12 months, the government could meaningfully pull the lever on and really accelerate and unlock progress on this?
Yeah, I mean, our first in-space demonstration is for assembly in space.
And when you say assembly, that's the sort of small modules moving into their place in the wider array.
Yeah, it's assembling truss structures. The the structure of the satellite is probably, if you imagine scaffolding, is probably the easiest thing to think about as an analogy, but it's constructing that in space, and that forms the backbone of the solar power satellite. So I think getting that accelerated along with our terrestrial wireless powered demo would be the things that we'd really value working with government on.
So it would be them giving you the go ahead and the green light to go and do that.
We don't need a green light, but any sort of financial or other support is always very, very welcome.
Is that the main bottleneck? Is it talent as well?
The UK is really well set up from a talent perspective. We've got a very strong space sector, about 50,000 people in the space sector. And actually, the space sector in the UK is going through a bit of a transition, as is the whole space sector. So we've then got strength in the UK in robotics, in semiconductors. So, yeah, most of the capability exists. At some point, there probably will be some sort of talent bottleneck, I expect, but that's some way down the line for us.
And I mean, it's, as you mentioned, we have this problem of generating ideas in Britain and not commercializing them. Do you think that other people then, they are experiencing these same issues, that it is just more of the same, that, oh, we can't get the money, we've got, unfortunately we'll have to publish it and then someone else will have to go off and do the work? Or is it an attitude thing?
It's all relative. I mean, my perspective is that there is a bit of a cultural and an attitude thing. I mean, the US just embraces risk, and they're phenomenal at it. It's probably, I'll say, the best the capitalist type structure, but they really do embrace and champion risk. And if you fail, you get a pat on the back and you go again. And that's such a different mindset, and it results in the fact that they're able to provide much chunkier quantums of capital towards early stage, higher risk businesses than happens in Europe or the UK. I mean, the UK is probably ahead of Europe on the kind of risk appetite scale, and also in financing. But even so, it's nothing like the US.
How could we change that? Is it just a question of having more spare cash, or is it something more complex than that?
The cash helps. Talent's important, and I think probably the culture. We've got the right infrastructure to scale businesses if we want to. I think if you look at the statistics, we actually do pretty well as the UK in terms of unicorns and possibly even decacorns compared to, say, Europe. But they're often in, say, financial services or that kind of thing. And I think it'd be absolutely wonderful from a jobs, from a growth, from a just where the world's going perspective, if we could get some of these sort of harder, deep tech manufacturing businesses to actually scale in the UK. And that has, I think, been a big problem for us. But it starts with capital, and then we've got to create this sort of positive feedback loop. It feels in the UK we've been in this negative feedback loop for a long time, where the economic conditions are challenging, which results in less investment, which results in challenging economic conditions. And I think Keir Starmer talked about this tepid bath of long-term decline or something. I'll mince the words, but
he said as he perfectly maintained the temperature.
yeah. But it does feel like there's a genuine desire to look to do something step change now. I think people are recognizing that the approach we've taken, certainly for the last 20 years, has not been successful.
But we've been talking in the past few minutes about space as an economic opportunity, but surely we can all agree that in fact it's about much more than that. Like it's a magnificent thing for the US that they put a man on the moon and all that. Is this just a business for you, or are you tapping into some kind of like mythic? What does it mean to you?
If ever I heard a loaded question.
It's mythic.
Good job. Take that one off. Yeah. Next question.
Space has always been a big passion of mine, and I've always believed in what space can do for Earth. I think it's such an important thing for us from an optionality and a future prosperity and abundance perspective. And so, yeah, I mean, trying to develop a space solar power business isn't straightforward. There are days when people tell you you're crackers and that kind of thing. I mean, frankly, we can be beaming power from space before the footings of the first SMR are put in place. It's that doable.
No NIMBYs in space.
No NIMBYs in space. Well,
flippantly, but apart from us, on space station,
yeah,
we do not
Exactly.
see you.
We don't want you to change the character of the neighbourhood. Actually,
but then is on those days, I know that what we're doing just has so many benefits in terms of opening up the space sector. So the space sector is about to go through a huge transformation, and I think we're seeing already how strategically important it is for defence and for all these other things, even with the way space works today. But we're actually pretty rubbish at space. We put this incredible stuff into space, but it's generally a bit dumb. It can't really move around all that much. But the transition we're about to go through will see the development of a range of different large modular structures that can benefit the planet in all sorts of ways. So it's space solar power, it's orbital data centers, next-gen SATCOMs. You can manufacture new drugs in space. People are manufacturing semiconductors. Space is going to be an important part of the future. And so I know that what we're doing is going to have a massive positive impact in terms of how we open up and use space. Innovation is a numbers game. We're building hypermodular structures. If you can build that, you naturally get good at space. Once you're good at space, let's go get an asteroid. Boom, boom, boom. It's about a future of possibility. It's about a future of abundance. And whilst there's all sorts of uncertainty in the world, and who knows where AI is going to take us, I am absolutely confident that having space as an option and an opportunity for humanity is something that can only be good.
The job we've got, so I don't want to belittle the challenge. We're trying to build one of the largest structures our species has ever built, so I don't want to belittle it. But actually, we're getting really good at manufacture. We're getting really good at logistics. We're getting really good at the ability to automate. That's kind of the era we're in. So we're not trying to do anything crazy. I just want to be Toyota. I would just want to be Samsung. I want to be those companies that look at a thing and say, right, how do I manufacture 1 million of them, and how do I get them into the right place at the right time? That's the challenge for space-based solar power, and that's why we're so incredibly excited about it. When you've got baseload technology such as nuclear, alongside renewables, with the ability for space-based solar power to point anywhere around the globe. So when we've got a fleet of these things covering the entire globe, and basically as people's wind is going up and down, sometimes it's too windy and the turbines can't work, or there's not enough wind and the turbines can't work. Hey, great, we'll move our beam to you in support. But when you've got overcapacity in wind, well, we'll sell our beams to somewhere that hasn't got that renewables. And so all of a sudden, you're not only providing the energy density that our species is desperate for. There's 7 billion people on this planet now. It's likely to turn to 9 billion by 2050. But at the moment, there is 2 billion people that have no access to electricity. They're using primary biomass. There needs to be energy equity. And therefore, you need resilience in energy. And the best way to get resilience in energy is by having diversity of energy systems. It's the best. It's always the best way, by having diversity and stuff. And so this is why we're so excited about space-based solar power.
Well, you mentioned that your antenna can target in 360 degrees. I'm imagining, because we are a proud maritime country.
Yeah.
Could it point out into space? Like, could you imagine having ships riding on like solar winds that you're blowing and targeting at them? Could it be a way that actually you could have vehicles moving that didn't need power? Is that an option as well, or am I being too fanciful?
In space or on Earth, or both?
In space.
In space. I mean, that's sort of way space travel go. I mean, people talk about solar sails and actually the sort of lightweight photovoltaic type materials and things we're developing. In fact, one of the things we have to design for is that it's effectively an enormous solar sail in space. So actually, we have to maintain sort of position and propulsion, and actually shape, because these are large, fairly flexible structures. Could we then use our beam to effectively provide propulsion?
Because people talk about ion engines, right?
Yeah. I expect it would need to be significantly higher power than what we're currently developing, but I'm not going to say it's out of the question. Power beaming in space is definitely a thing. It's growing. There's a number of different companies that are looking at the sort of space energy network, shall we say. So both with lasers and with microwave.
What to fund to fuel other satellites.
To fuel other satellites, that's right. So that's already starting to happen.
On Mars and on the Moon, and it's going to be a big challenge to turn the ice into fuel.
Yeah.
I suspect, which is Plan A. But why not just put some of your arrays in orbit?
Yeah, exactly. It's good for lunar power. NASA are looking at space-based solar power for the Moon. They're looking at sort of micro nuclear reactors as well. But space solar power, again, it's got a range of real benefits that mean it's likely to be a part of the mix as the space sector evolves.
You're talking about scale as well, and we've had a guy on the show, Peter Haig, who is a big champion.
Twice now. We like him that much.
Wow. And, that's my aspiration.
He's a champion of having super heavy launch capability outside the US, if you can imagine such a thing. And he thinks that we should be building some kind of launch capability that could host Starship or New Glenn. Do you think we should be doing that? Like if you were kind of running the UK space sector, or if you were Prime Minister, is that what you would do with your magic wand?
I think access to space is going to be so strategically important. I mean, you listen to how the US is in some circles talking about Starship. There's a good book, actually. I think it's called The Future of Geography, and by a guy called Tim Marshall. And part of his thesis was that it was the waterways and controlling the waterways that used to be the thing. It has been the thing that's made the sort of US the dominant power globally over the last 60 years, whatever. But actually, it's space that is the new waterways. That if you can control space, you can you really do continue to be that dominant power. I think that narrative's correct. The other way they're talking about Starship is you don't need planes and boats. Within an hour, you can ship 100 tons worth of stuff. And if you've got multiple starships, 100 starships,
with colossal emissions.
Well, I can I can throw in the usual sort of response around similar to a transatlantic flight and that kind of thing. Starships,
ignore him.
Expect Starships slightly more than that. But although what I would say, if you do want to keep it in, is we've had a full end-to-end life cycle analysis done, and including all of the launch, you're still about half the carbon footprint of terrestrial solar. Because you get that much more capacity out of your panels. So you've then got this ability to just shift kit and equipment not instantaneously, but very, very quickly anywhere across the globe.
Well, the DoD is quite interested in this, as I understand.
Yeah.
You send personnel to another country, they could be there in an hour, no matter where. Like we could be in Australia in an hour.
Exactly. And you can imagine as potentially more and more infrastructure and assets and potentially critical infrastructure assets end up in space, you're going to want that capability. Our geographic location is not ideal for getting. You're not really going to get to geo from geostationary orbit from here terribly effectively. That said, yes, I probably would be looking at whether we can do something with heavy reusable launch. And I think as the sector evolves, points where you will naturally launch to, you'll end up with equivalent of depots or ports and things, and we'll build out the space infrastructure in that way.
Well, I mean, I think to take that line about the waterways further, right? Colonization of other planets is going to become possible and desirable, and people are going to start doing it. how do we then avoid being left behind, being, I don't know, somewhat like Imperial Germany, right? Whilst
Yeah.
Britain and France have already seized all the good bits
Yeah.
and feeling a bit left behind. Like, what's does that timeline look for you like for you? And do you think that this is a critical thing we need to build up, or can we sort of say, look, the West will do it? Like, where does Britain sit in this?
I think we should absolutely be doing it, and actually, it's a now thing. So there are very few sectors ever where you can go, oh look, there's the step change. Starship working is the step change for the space sector, and UK is an island nation. We've got some brilliant people, but actually our factors of production are pretty limited. Space ends up being, well, yes, by definition, it's most of the universe is outside the Earth. But even in the short run, the ability to deliver the things I've described, so energy, comms, stuff from the moon, potentially asteroids, is there. The UK needs to move now, though, because the barriers to entry to this are going to be really high if you don't move. If you don't move first, it's a cost of capital thing. Once countries have been through the cost of capital curve, or companies have been through the cost of capital curve, it's going to be very hard to catch up. So I don't think there's a second mover role for countries like the UK here. I mean, probably perhaps as Europe or something, you could potentially get there and do something. But I mean, this space will be bigger than AI. We should be putting a hell of a lot of effort into space right now.
But tell us, how do we do it? Imagine there are cabinet members listening. What should they be doing this afternoon to make it happen for us?
You've got to prioritize space, and it does come down to orders of magnitude more investment. And I know it's not just about the money. I think we can do the rest of it fine. But if I look at the amount that's going into, say, well, you pick your project, but AI, fusion, boom. This is it's such a strategically important sector. So there needs to be, I'm going to say, 2 orders of magnitude more investment. And by the way, that shouldn't really trouble the scorers too much.
Yeah, I mean, it's a rounding error.
Yeah, it's a rounding error. We putting
1% off Motability.
Just on the space sector generally. I mean, we were the world leaders in sort of private finance into the space sector, but I am going to say, as usual, as quite often happens, we're falling off the back of the boat again as everyone else has caught up. So if we really do want to capitalize on what is an incredibly important opportunity in terms of a bright future for the UK, we need to stop thinking about that's what we put into space last year. So maybe if you could have an extra %, you're doing well. This is an order of magnitude. This is a step change thing, and it's a step change based on the recognition that you can use space in a completely different way, develop these large hypermodular structures that massively benefit the planet. So if you want to be a leader in AI, you could put some orbital data centers up there, or you can power them from space with space solar power. Industry experts sort of suggest that the cost of AI will trend to the cost of energy. So if we can't really sit here in the UK and say we're going to be leaders in AI and have the most expensive electricity, most expensive energy in the world, which is pretty much where we are today. So you've got to try and square that circle or narrative, and space can be a really, really important part of that future.
And would that be with some NASA-like body that's very powerful, has lots of money, and runs projects on its own, or would this simply be, allowing startups to have more access to capital? Like how do you actually see this money being spent?
Yeah, I'd weight it towards the latter. So I think we've got this body of 50,000 people in the UK that are already in the space sector. It's going through a bit of a transition because some of the traditional companies are slightly struggling at the moment. But that talent,
you sort of Boeings and people.
That sort of equivalent, yeah. But that talent can be reshaped and support what there's. If you look at a sort of ranking of top companies doing stuff, actually in the UK we've got a great company doing semiconductors in space, got a great company making drugs in space, you've got companies doing orbital data centers. You've got fantastic companies doing next-gen propulsion. You've got us doing space solar power. That's where the space sector is going. And so if we can support those with the support of a capable space agency, so it needs to be technically competent, doesn't need to do everything, doesn't need to be a NASA, but it needs to be able to guide and provide the structures and frameworks where needed. We can absolutely create a hugely positive future for the UK through space.
And go on. I mean, I know we've really pushed you on the sort of nitty gritty, and I hope that our listeners will put up with our curiosity on this. But so what we need basically someone to come out and say, okay, we're going to do this. We're going to, 2 orders of magnitude. Then we're going to have someone at the top who says, right, you're going to do X, and we're going to give you a load of money. Is that what you mean? Is that what you mean by direction and frameworks and things?
It probably would benefit from having someone who's responsible. And I mean, I'm of the view that actually strong government, insofar as a government that is knowledgeable and capable and can back itself, is really important. And so having somebody or somebody within government that has a view of how the space sector can evolve and can sort of help I'm an advocate of market shaping rather than addressing market failures. I think that's been a big challenge for what we do in the UK. What's really important then is that we actually support businesses like Space Solar, but businesses that can be the tier 1 companies. So again, part of the sort of UK economic and industrial policy the analogy I'd give is if there's an opportunity to build houses, the UK tends to go, great, we'll fund a competition, we'll fund some brick builders. So you end up with loads and loads of companies that are sort of in the supply chain, but we're not creating those businesses that can be the sort of pinnacle, the spearhead that crowds in public and private finance and ultimately funds the supply chain in the UK as well. So you've got to have some of those in there. So yes, a strong space agency, but then linking it right across government, because if space does its job well, it's about energy, it's about health, it's about communications, it's about a range of different things across government, which is actually something the UK did well for a few years, and it's sort of slightly reshaped itself and moved away from that. So I think that would be another important thing to bring in.
You mentioned health and energy and housing, and all those cases, people in those sectors would argue that it's regulation that is holding them back, particularly in housing. I wonder if there's like one bit of regulation you could axe or change. What would it be? It'd be as specific as you can.
I'm gonna push gently back against you. My experience of the regulators in the UK for space has been really positive. Actually, the UK's sort of quite rightly seen as a bit of a leader in regulation in space. They've got that nice balance of being sort of viewed globally as if you've got the stamp from the UK, it's been done well, but actually incredibly flexibly. So around small satellites, around some of the new regulation around in-orbit servicing and things, genuine leaders. So I don't think there's a particular regulatory blocker, other than a willingness to engage and create the rules of the road and regulations for what is the Wild West at the moment. There aren't effective rules and regulations for space. It's not even like drive on the left hand side of the road. There's no roads. Yeah. So that's the transformation that the space sector is going to go to. But what an amazing opportunity! What a fantastic! And actually, the regulators have been great with space solar power. I've never seen people so energized. This is great.
I mean, even on the grid connections, because that's obviously one of the things that people here on Earth,
it can take 15 years.
Yeah, it can take 15 years, right?
Onto the grid.
But and yet they're keener with you. They're more willing to do it.
We've had initial conversations with Ofgem and NESO, so that's that part of the conversations sort of earlier. All I can say is that they've been very positive and very engaged. This is an important potential because you can potentially beam off-grid as well to different off-grid points.
Oh, what, that you could actually sell directly to people rather than put it onto the grid?
Certainly to businesses rather than that becomes part of the solution. They're engaged on wireless power transmission terrestrially, which is brilliant. So again, to address some of these grid congestion points, what can you do with wireless power terrestrially? And I think there's such an acute pain now around these grid connections that a lot of attention is being addressed to it.
As you actually think that the noise that we're hearing about this is the sort of last we will hear, because actually there is great effort being put in to make this no longer an issue?
I will concur on the last point. I think there's a lot of effort being put in. I doubt it's the last we'll hear about it. I think it's a really nutty challenge. There's some great people working on it, and I think it will move in a good direction. But this is the bit of the energy system cost that is the challenge. So when people come to you and say, we just need some solar and some batteries, actually, it's the grid that's the cost of the upgrade to the grid is the unsaid cost in all of this. So, and that's where something like space solar power with its baseload capacity starts to become
that
really
can fire
important.
anywhere.
Yeah.
I'd be interested going back to that thing you were saying about the regulations in space, that there are no roads.
Yeah.
I mean, are you talking now sort of, because we've already got these problems of satellites filling up orbits and people worrying about debris. Are you sort of talking about now having, I mean, almost like a maritime code for space?
Yeah.
And what, always,
Pass on the left and
green and red lights
Yeah.
and things.
Yeah.
And I imagine that would need to be something more global.
It will, yeah. But there are precedents now from maritime or for aviation. This is stuff human beings are actually really good at.
Yeah.
But typically you need to actually do something for the regulation to come and join it. It's very
it needs to become a problem
yes,
first.
for people to actually solve it. I mean, my view on the space sector is that it's understandable why we use it as we do today, because we were launch constrained, and you want to launch stuff to be as far away from things as possible, so they don't crash into each other, because we've not had the ability to launch enough propellant and things that you can maneuver consistently, and you don't want to interfere. But actually, in every system, from the microscopic to the macroscopic, actually in the end you evolve as clusters / nodes and connections between those clusters, and it's purely down to economics. What we're about to go through in space is the equivalent of humans coming from fields into villages and towns. That economic interaction, economics in its broadest possible sense of interaction and exchange, provides such a boost to things. And so in space now, my view is you want to move towards clusters and large structures. And I think the large structures will come first, because they're probably, from a regulatory and sort of outer space law perspective, probably slightly easier to do because they're normally a contiguous thing. But it's coming together as clusters that will transform the space sector. And so rather than scattering lots and lots of these thousands of monolithic satellites, at least have them in little villages equivalent of, so that
I suppose because that makes the sort of manoeuvring of them a lot easier.
Yeah, but you've then got stuff together that people will care about, so you won't want to crash into them. So you'll make sure that bit's clean and that bit's clean, and you'll have some rules around it. And then the economics of sustainability work, because at the moment it's like having a playroom and scattering your toys as far apart as you can. Go clean that up, kids. Not a chance. Actually, if your stuff's in a pile, you can clean it up. It's the economics of sustainability start to work. So I think it's going to be a really hard change, because there's a lot of incumbency in the space sector that just likes the way it works. But actually, it's a stupid way to use an asset. And I'm hoping that what we do at Space Solar will start to move the sector in what is a much more sensible direction.
And I mean, and you don't think we'll have this problem of, what do they call it, like a junk Earth, where we're locked in because there's so much debris?
Well, no, I do have a concern. Actually, if Starship is used in a not thoughtful way, you can just, we're already at 50,000 orbiting space assets or something. And that's, is it 3 orders of magnitude increase? It's orders of magnitude increase in the last decade, basically. So if you can fill a Starship up with these things now and chunk them out, boom, you are starting to build up problems which will be hard to solve. They nominally deorbit, but actually from an environmental perspective, that doesn't make much sense. It's not very sensible. From an economic perspective, actually, if you've got your assets in space, you've spent a lot to get them there, why not keep them there? I just think if you can start to move towards this clustering and be a bit thoughtful about it, Starship can change the world in an incredibly positive way.
And what's the Britain that you'd like to see in that vein in 50 years? Where could we go? What could we be?
I mean, I believe hugely in both the history and the future of the UK, and I really, I'd love to solve the challenge that we talked about, which is that we're terrible at scaling stuff. But I hope it's a Britain that is one of something that's a flagship for the world in terms of innovation, building abundance, being able to deliver that innovation, one where power's not a problem, one where we're perhaps leaders in the space sector. I think would be a really good thing. One where in 50 years' time, the generation that's coming then have a bright future ahead of them. And I think we want to help bring the whole world with us. I think we've always been pretty good at the sort of links and being a bridge between nations. And it does feel like we're at a real juncture in all sorts of reasons globally at the moment. I mean, I wouldn't want to be predicting the future right now, frankly, with the quite what direction's AI going to take us? Where does geopolitics sit at the moment? But I do think the sort of core values and the institutions we have in the UK, I think, put us in a good position to have a positive influence on the world. And I'd love to be able to look back in 50 years and say that actually now was a really pivotal time where, and it's not just about government, because governments come and go, but governments and the people of Britain today actually seized the opportunity and addressed the fact that, frankly, we are doing on this continual decline. And whilst we talk a good game, we've genuinely got to sort of step up, look for orders of magnitude change, take higher risks, and try and deliver a bright future for our kids.
I mean, I have to say, with this rise in uncertainty, you sure you're not regretting making your thing not weaponizable?
No, I mean it's really important to what we're doing that it's not. I mean, we're all for doing stuff that increases sort of global security and that sort of thing, but no, we want to make the world a sort of safer place with if we can provide sort of energy security globally. I think that obviously is a really powerful thing. But my perspective on uncertainty is one of options. So whilst my career was mainly in the space sector for the last X years, it's been in strategy, which for a physicist who turned up with first job after university, expecting to do an engineering job, and that just happened to get postponed. Would you mind doing some market intelligence for 6 months? Okay, fine. And 20 years later, I've done strategy roles for most of my career. And in times of uncertainty, strategy 101 is give yourself some options. What we're doing with space solar power is just an incredible option. The end game is insanely good, but actually it's a no regrets move because you create terrestrial wireless power, you create in-space assembly, you create so much positive potential for the world. And we need this option on the table now.
Yeah, that I suppose then starts, as you say, creates those virtuous cycles that then allows us to be the next people.
Yeah.
Before we let you go, is there anything you might ask of our listeners? Some people like to, there are particular hires they want to make, or maybe you want investment, or simply you want to leave something ringing in their ears.
Well, the space sector is changing. It's going to be a huge part of the future. Space solar power is a really important part of the future energy mix. We're raising funding at the moment. If you know anyone that's interested, we'd love to talk, and we'd love anyone that wants to join us on the journey as a partner, ultimately as an employee, and particularly as an investor right now. But absolutely brilliant to have the opportunity, and thank you.
Well, thanks for having us here, and we look forward to hosting you in low Earth orbit sometime soon.
Yeah, exactly. When you make it up, we will we'll get you a drink at the bar.
So that's my chance for appearance number 2. I'm in. That's a deal.
Let our next meeting be in the British low Earth orbit habitat.
Done. Done.
Well, thank you, listeners. We will be back in a few weeks' time, but for the moment, subscribe on Substack.
Consider sponsoring us.
And thank you very
Consider
much for listening.
advertising.
Goodbye.
Emissions. What the hell are you thinking about? We love emissions.
It just slipped out.